Hi, I'm DeRozan. I'm junior students in computer engineering, and this is my video for EECS203 IA implication. So today I want to talk about the contrapositive part of the EECS203. So if we're trying to say that two statements are equivalent, we have to show that their truth table are equal, right? So first, we have these two statements. If I pet my cat, then she's happy. And if my cat is not happy, then I didn't pet her. So we need to show that these two statements are equivalent. We can simplify it into if P, then Q. The P part is I pet my cat, and H part is she's happy. So the second one, we can say this like, if by H, then it means that my cat is not happy, then by P, then I didn't pet her, right? If we show that these two statements are equivalent, their truth tables are same, so these two statements are equivalent, then we can use like by H, then by P to substitute P, if P, then H, right? So we first state the if then truth table, P, H, if P, then H. We have already learned it. So this is true, false, false, true, false, and false. So from the if true statement, we know that this true to true is true. If true, then false is false. If false, then true is true. If false, then false is still true. So now the important part is, how can we list this one? We first still list P and H. And we do not directly list if P, then if by H, then by P, because you cannot directly get it, right? You need to list something else. So what can you list to like directly get the by H to, like if by H, then by P? This is like by H and then by P, right? So we still list this one to make it like exactly the same as the left side. True, false, false, false. And what is by H? This is false, right? Because H is true, so this one's easy. So by P is the negation of the P, so this is false, and this is false, and this is true, and this is true. Now we can use the if then statement. False to false is true, true to false is false, false to true is true, true to true is true. So now we can see that these two statements are equivalent. Like for this part, it's true, false, true, true. And for this part, it's also true, false, true, true. So these two statements, if P then H, and if by H then by P, are equivalent. So that is contrapositive. We can use if by H then by P to substitute if P then H. So we have an example here. For all integer x, if x squared is even, then x is even. So first we try to do it like in the direction, direction from the left to the right. So first thing we're gonna do, like we're trying to prove it. Then so like for all integer x, x is even, so we can do it simply just like x squared equals 2k, right? And you need to prove it like x is even, so you need to list x as square root of 2k, but you have no way to show it like why is that even, right? So it's not an easy way to like prove from the left to the right. So now it's time to use the contrapositive. Like first we need to list the contrapositive. So what is the contrapositive of this one? This is the if part, and this is the then part. So this is P and this is H. So by H to by P is if x is odd, then x squared is odd, right? So we need to prove this. If we prove that if x is odd, then x squared is odd is true, then we got if x squared is even, then x is even. Okay, so now we can say that x equals 2k plus 1, because x is odd and k belongs to v. So any integer. So how can we like show x squared? Just like x squared equals 2k plus 1 square equals 4k square plus 4k plus 1. We can show like something else here. It's 2k plus 1, 2k plus 1. This is 4k square, then this is 2k, and another 2k plus 1. And now we get this one. So we can say it's like this: 2k squared plus 2k and plus 1. So by this we can show that, because this is an like even numbers, right? Because 2 times an integer, arbitrary integer, it's even, and we know that even numbers plus 1 is odd numbers, because we can show like this is 2k, or say anything else like 2j for the whole part, and 2j plus 1 is odd. So now we got like, we can prove that if x is odd, then x squared is odd. So now we proved like if x squared is even, then x is even by the contrapositive method.